We're looking at 16 through 21 from the Taylor series multiple choice worksheet, number 16. The sum of the infinite geometric series. So we know this is geometric series. We just have to figure out what the ratio is. So we see that the pattern for the numerator is multiplying by 3, denominator multiplying by 2. So the ratio will be 3 halves. So, 3 eighths. Multiplying by 3 up the numerator by 8 in the denominator, so 3 eighths. We know 3 eighths is less than 1, so we know there is going to be a sum for this series. So sum is just going to be a sub 1 over 1 minus r. So a sub 1 is 3 halves. That's the first term, divided by 1 minus the ratio. 1 minus 3 eighths is 5 eighths. 3 halves divided by 5 eighths equals 24 over 10, or 2.4. Okay, number 17. What are the values of x for which the series converge? So we know we have to go through ratio tests. So after we find the interval of convergence, we have to also test the endpoints. So first off, ratio test. So the limit as n approaches infinity for a sub n divided by a sub n plus 1. So, a sub n plus 1 divided by a sub n. So here's a sub n plus 1. Divided by a sub n is the same thing as multiplying by the reciprocal. And then we can look to see what how this can reduce and simplify. So x minus 2 to the n plus 1 reduced to be x minus 2 to the n times x minus 2. And denominator is n plus 1 times 3 to the n times 3. And we see x minus 2 to the n reduces, 3 to the n reduces, and the n over n plus 1 will just give us a coefficient of 1, and then we're left with x minus 2 over 3. So we know the series will converge whenever absolute value of x minus 2 over 3 is less than 1. And if I multiply both sides by 3, absolute value of x minus 2 is less than 3. So we know that this is in the form of x minus c is less than r. We know that the ratio of the radius of convergence is going to be 3, and we know the center is going to be 2. So if that's the case, then we know x minus 2 will be between negative 3 and 3. If we add 2 to both sides, x is between negative 1 and 5. So now we have to make sure that we test the endpoints, make sure we can determine whether the endpoints will converge or not. So we can plug negative 1 into our series here. So plug negative 1, we get negative 1 minus 2, which is negative 1 minus 2 over negative 1. So this is negative 3 to the n over 3 to the n. And this essentially cancels out to be negative 1 over n. Since negative 3 over n over 3 to n, which is canceled out to be negative 1, so negative 1 over n, we know negative 1 over n will converge. Okay. And then we look at 5 minus 2 to the n over n times 3 to the n. And this gives us 3 to the n over 3 to the n. Cancels out, so we get 1 over n. And we know 1 over n will diverge. So we know that 5 will diverge and negative 1 will converge. So that's our answer here. Number 18. We have a Taylor series for sine of x in this form that's given here, and if f is a function such that f prime is equal to sine of x squared, then the coefficient of x to the 7th about x equals 0 is. So we know that f prime of x is equal to sine of x squared, and if we expand sine of x squared using what we know here, we can rewrite this as a polynomial as a Taylor series or Maclaurin series. So I can replace every x we see with x squared, which gives me x squared minus x to the 6th over 3 cubed, x to the 10th over 5 cubed, over 5 factorial, sorry. And now we have an expression that represents f prime. Okay, and we want to get to f of x. So to get from f prime to f of x, we have to find the indefinite integral. So we want to find the indefinite integral of x squared minus x to the 6th plus x to the 10th, and then we go through power rule here. So we get add 1 to the exponent divided by that exponent. So s cubed over 3 factorial, x 7th over 3 factorial times 7, x to the 11th over 5 factorial times 11. And then we're just looking for the coefficient of what's attached to the x to the 7th. The coefficient for x to the 7th, which is 1 over 3 times 2 times 7, or negative 1 over 42. Okay, continuing on with next page here, 19. We have a series here. We know the Taylor series about 0 for which of the following functions. We know that we should be able to recognize this to be the Taylor series for e to the x, because we know e to the x is 1 plus x. It's in the form of 1 plus x squared over 2 factorial, x to the n over n factorial. So therefore, e to the negative x would produce negative 1 to the n times x to the n over n factorial. Right? So we have e to the negative x. Okay, number 20. For what values of x does the series converge? We know that the series will converge whenever x is less than negative 1, because when x is less than negative 1, essentially n to the negative 1.1, for instance, which is a value less than negative 1, is 1 over n to the 1 plus 1.1. And we know that 1.1 is greater than 1 if we consider this as a p-series. Then any p-value that's greater than 1, the series will converge. All right, the complete interval of convergence. So we have to go through our ratio test. So limit as n approaches infinity for a sub n plus 1 divided by a sub n. I'm going to rewrite this as x plus 1 to the n over n squared. Just something, instead of using k, we'll use n, something that's more familiar. Okay, so now here's a sub n plus 1 divided by a sub n, or same thing as multiplying by the reciprocal. We can reduce the x plus 1 to the n, and we're left with x plus 1, and then we see the n squared and n plus 1 squared will just cancel out, reduce. We're left with the absolute value of x plus 1 that's less than 1. So here is our radius, here's our center. So in other words, x plus 1 is between negative 1 and 1, and we subtract 1 from both sides. We know the endpoints are at negative 2 and 0, so we have to test the endpoints. Plug negative 2 into the series here. So negative 2 plus 1 is negative 1 to the n over n squared. This will converge by p-series, and so p-value is greater than 1. If we plug 0 in for x, we get 1 to the n over n squared. This is also will converge by p-series. So we know that the endpoints will converge, so answer choice E.